Can radiation, like X-rays, be visible? Well, yes, they can, but not with the naked eye. A camera can, in a way, see radiation, since when the sensor is hit by that kind of energy, it's temporarily and locally disrupted, and you end up with some weird streaks or point-like artifacts. For example, this is what happens when you have a camera, like your phone, recording while going through an X-ray scanner at the airport. You can detect when the X-ray bursts happen, as they would leave noise-like marks for a few frames here and there in the video. Of course, it's more visible when slowed down and the levels are enhanced. At normal speed it looks like a glitch you can barely notice. Around May 20th, we had a peak of solar activity causing massive aurora borealis on Earth, even at unusually low latitudes like London, Holland, and northern France. And during this occasion, one of NASA's active Mars rovers, Curiosity, was shooting video to detect and measure dust activity on the surface of Mars. There was a major solar flare directed towards the planet, exposing it to high levels of X-rays and gamma rays. If there was some astronaut present, it would be the equivalent of 30 chest X-rays. It's perfectly visible from the rover's video recordings. There's some snow effect and strange streaks all over the frame. That's the effect of the radiation that was impacting the sensor. It was the biggest radiation surge Curiosity has ever measured. So why doesn't Earth get these effects like Mars does, even though it's closer to the Sun? Earth's magnetic field generates an invisible bubble around our planet called the magnetosphere. It's really like a shield protecting us from much of the Sun's harmful radiation that can reach other unprotected places like Mars or the Moon. And what happens instead on the International Space Station? Although being outside the atmosphere, the ISS is still located in a safe space region thanks to the magnetosphere. However, by lacking the protective effect of the atmosphere, the exposure is higher than on the ground. And protective measures are still taken during solar storms. For example, the astronauts temporarily take shelter in more shielded areas from radiation. Going back to cameras, radiation impacts them too on the space station. Those cameras that have been on board for even just a few months develop incremental damage to the sensor pixels, which appear as random dots of red, green, blue, or their combinations. So, in addition to protecting human beings from radiation in space, we must also protect the electronics of circuits with special construction techniques and materials, so that computers and devices do not go crazy compromising the missions.